This next lecture is looking at mole ratios. And what this means is it's a new conversion factor that allows us to switch identity. So let me give you an example. Let's say that I wanted to make a sandwich. So to make a sandwich, I need bread plus turkey to make a sandwich. Okay, how much bread do I need? Well, I need 2 pieces of bread and I need 3 pieces of turkey to make 1 sandwich. Okay, so what I just did here was I balanced my equation using these coefficients. So if I asked you to tell me the ratio, how much bread do I need to make a sandwich? You would tell me, oh, well, you need 2, and I'm just going to abbreviate, 2B for breads, 2 breads for every 1 sandwich. Sand. What if I said, well, what's my ratio of turkey per sandwich? Well, you would say, you look at this number and you would say, oh, well, there's 3 turkeys for 1 sandwich. What if I asked you the ratio of bread to turkey? Well, you could tell me 2 breads for every 3 turkeys. And the reason why we need to know these ratios is because what if I said, you know what, I have 6 pieces of bread. How many sandwiches could I make? So bear with me here. So just like with previous things, I'm going to take what I know. So I'm going to tell you 6B for breads. And I want to go from breads to sandwiches. So I need to find that ratio of breads to sandwiches. Now, to get rid of bread, B, I need to have bread on the bottom. So my 2 breads would go down here for my 1 sandwich on top. So my breads cancel out. So I would do 6 times 1 is 6. 6 divided by 2 is 3 sandwiches. So I switched identities. I was given breads. I was able to go from breads to sandwiches. That is what this mole ratio is going to tell us. So let's erase here. Okay, so let's look at a real chemical equation. So I've got SO3 plus H2O to give me H2SO4. So let's balance this equation, just like what we've done before. There's not really space for me to do it down there, so I'm just going to write my elements up here. S, O, and H. S, O, and H. I have 1 S. I have 3 O's plus 1 O is 4 O's and 2 H's. Over here I have 2 H's, 1 S, 4 O's. So hey, rock on. We're balanced, balanced, and balanced. So that tells me that I have 1 of all of these compounds. My coefficient is 1. So if I asked you what's the mole ratio of sulfur trioxide to water, you would tell me, oh, it's a 1-to-1 ratio. 1 mole of SO3 for every 1 mole of H2O. What about if I compared SO3 to H2SO4? Again, we look at that coefficient. I would say 1 SO3 for every 1 H2SO4. So let's look at a problem that says how many moles of H2SO4 are formed when I start with 1/2 of a mole of SO3. So I'm going to start with what I'm told, 0.5 moles of SO3. So I want to compare SO3 to H2SO4. So I'm going to use this conversion factor, and I have to have, since I started with moles of SO3, I got to have moles of SO3 down here to cancel it out. What do I want? H2SO4. So I'm looking at that ratio of H2SO4, and we know it's a 1-to-1 ratio. So what is anything times 1 divided by 1? It's going to be the same number, right? So since I started with a half of a mole of SO3, I'm going to end up with a half of a mole of H2SO4. When it's a 1-to-1 ratio, we'll get the same answer as what we started with. Now, oftentimes it's not a 1-to-1 ratio. So let's look at this example. I am told that I have 2 NOs. There's 1 NO, there's 2 NOs, plus oxygen, O2, yields 2 NO2s. There's 1 NO2, there's 2 NO2s. So if we balance it, let's just make sure I have 1, 2, 3, 4 oxygens on the left, 1, 2, 3, 4 oxygens on the right, 1, 2 nitrogens on the left, 2 nitrogens on the right. Okay, so we're balanced. That's the important thing, number 1. So now let's look at the ratio of NO to NO2. All right, well here's NO to NO2. All right, so it's a 2-to-2 ratio. Let's look at oxygen. The coefficient in front of oxygen is a 1 to NO2. That's a 1-to-2 ratio. So how many moles of NO2, here's where we want to get to, are formed from half of a mole of NO? So let's start with what we're given, 0.500 moles of NO. So we want the ratio of NO to NO2, which is NO to NO2, this ratio right here. Again, I have to have, to cancel out, I have to have moles of NO on the bottom, right? I need it to cancel out, and I need moles of NO2 on top, which we're just shown that it's a 2-to-2 ratio. And we know that 0.5 times 2 divided by 2 is also going to give us 500 moles. Now, here we can see that this cancels out of NO2. Okay, let's do another practice one. This time we're told we're given a half of a mole of oxygen, 0.500 moles of O2, and we want to get to NO2. So now we're going to use this conversion factor. I want to compare oxygen to nitrogen dioxide. So I have to have which on the bottom? It's what you want. What do I want? I want moles of NO2. That's what I want. What do I want over what I got? I've got moles of oxygen. And we want to make sure that moles of oxygen and moles of oxygen are diagonal from each other to cancel each other out. So how many NO2s did we say right here? 2. So how many moles of oxygen, that coefficient in front of there? 1. So now we just need to do 0.5 or 1/2 times 2 divided by 1, and we would get 1 mole of NO2. So hopefully this is helping you see that having a balanced equation will help us to see those coefficients of relating from one species to another species.